coil connected in a series with a shunt produces a magnetic field. The magnetic field produced by the coil interacts with that of the stationary magnets. This causes a torque to the magnets and subsequently turns the needle.
The inner coil of the multimeter has a small surface area which creates resistance. Thus, electrons in the coil require push or voltage to move around the coil and produce a magnetic field, which creates a resultant torque to the needle. When calibrating, we took readings on the voltmeter for 10, 20, and 30 volts. We then placed dots on our design where 10, 20, and 30 volts were. We then took the average of these dots to find out precisely where 10, 20, and 30 volts on our design would be. We also did this for the ammeter.
We have a thick outer coil and a thin inner coil. Inside the thick outer coil, we have an axis of rotation on which the magnet is suspended on. Over here, you can see the magnet on the axis of rotation connected to a needle which turns according to the voltage and current going through the coils.
We are now measuring voltage. It's at 0 as you can see. Then let's go to 10. So that's 10V. Let's go to 20. So that's 20V. Let's go to 30. So that's 30. So that's 0, okay, as you can see. So let's go to 1. That's 1. Let's go to 2. That's 2. Let's go to 3. So that's 3 amps.